Well, hello everyone, and this is another one of the videos that I'm producing for the ITS2300 Data Networking class. This particular one is a quick summary of IP forwarding and by implication routing tables. So let's jump right into it. As I usually do, quick review of where this lives in the textbook, the TCP/IP Illustrated book by Stevenson Fall. You'll find this particular section in Chapter 5, which we've also used to look at more of the fundamentals of IP. And pretty much this one's very simple. You want to read through the entire section on IP forwarding, particularly the forwarding table, and don't get the forwarding actions use kind of a mathematical notation to discuss picking entries in a routing table that that isn't terribly profound, but I think if you sort of get past that, it basically just talks about what the router does with the routing table that we're going to look at in just a second to figure out what it needs to do. And this is IP forwarding is one of those things where the more examples, the better. So by all means, go through the examples in the book, and here in this video, we'll go through my example. And so hopefully we'll kind of get that nailed down. So here is and I'm using the draw.io package, and I'm going to enlarge this a little bit so we can see what we're doing here. Let me see if I can get this on screen. I can move some of the stuff behind me. There we go. So that should hopefully be reasonably visible. Let me move this just a little bit. Okay, I think that'll work. So what we have here, and I'm going to zoom out a step just so you can see the overall layout. So what we have here, two routers. This is the one that connects us to the internet, which is up here, and I call that R1. R1 has R1 has two interfaces. It has the one to the internet. It has the one that goes to an Ethernet network, and I'll just show one host here just to illustrate the point. I've made all the prefixes /24s, so just to keep things simple. On this Ethernet is also a connection to a second router, which in turn has another Ethernet connected behind it. I might do this if I wanted to protect this network in some ways that isn't the same as here. I want to protect these networks from each other. I might have more networks here. I was trying to keep this relatively simple, so I just want to get the basics across, and then said the readings in the examples in the book are very much recommended. All right, so let me pop this up a little bit bigger. Right, so what we want to do here is look at the routing table in R1, and then sort of see what happens. Right, so in R1, the first thing I'll usually do is figure out what the default is. So what does R1 know? And if it doesn't know, where is it going to send it? And so let's start with that. And so we'll do 0000/0 as matches any address, and I'm also going to label it default. Right, and at this router here, R1, we are going to give R1 all the information it needs to deal with the network that is behind it, because the rest of the internet wouldn't know that. But if for anything that isn't connected either directly or indirectly to R1, we would want it to go out to the next router up in the hierarchy. So let's so the next hop would be the router that we're connected to upstream. So the next hop here would be 172. Whoops, I'm in the wrong place. Click there. 172.17.1.254. And notice that this obviously has to be on a network that that this router understands. The interface, which our reading talks about, we specify basically which network interface the traffic goes out on. In our example on the board, we used like ETH0 or interface names, and you'll see that in a lot of routing tables. In a lot of documentation like this, where you might not necessarily have the interface names noted down, although in our lab exercises we do. And you see this in some operating systems where I basically use the IP address attached to the network to the interface as a placeholder. So in this case, because I didn't give the interfaces names, what you might see in this kind of a configuration is 172.17.1.25, which basically says this interface here, the one that has that IP address on it. Okay. Obviously the next entry would be anything on this network, because in order to reach that next hop, I need to know how to talk to this network. So I need to have an entry that says 172.17.1.0/24, which is this subnet here on the north side of our router, up on the going up from the router. Next hop, there's no next hop. This is direct connection because it's on our Ethernet. And of course, it will go via the 172.17.1.25. All right. So these two entries here basically tell the router any traffic that goes to that particular subnet. You put out directly. On the via Ethernet, do ARP, find the Ethernet, or send it out via direct to Ethernet on the interface that has this IP address on it. Let's do the same thing for the Ethernet that is south of R1. So this guy here, and it is 172.17.2.0/24. So anything on this network here is also direct, and the interface will identify by 172.17.2.254. All right, so if this host sends, and it would have this router here as the default route. So if this PC down here sends traffic somewhere on the internet that isn't within this network, it would send it to R1 because that's its default route. R1 would get that packet. It would compare it to its all the entries in its routing table. The only thing that matches is the default route because it's going out of our network. The next hop that the router needs to use is 172.17.1.254. Now it's got to has to take that address and say, how do I reach that? And of course that matches the second entry here direct connection via this Ethernet, and we're good to go. So now we've created a we are not done, and this is why this is just a slightly more interesting example. Because right now, if this PC here tries to reach this PC here, it'll send. So we're sending to 172.17.3.19.24. This guy here only has a default route, so it will send its traffic via the default route. It's not. This PC only knows the local Ethernet and that this guy is its default router. So it now sends its traffic up here. This router will now take 172.17.3.19 and compare it. It doesn't match. Everything matches the default route. It doesn't match here. It doesn't match here. So I'm going to pick the default route. I figured out how to get to 17.1.254. The traffic will go here. This router here will have an entry that knows that this network is part of this organization. It'll send the packet right back. This router will send it back, and the packet will basically bounce up and down between those 2 points until the time to live expires and it gets deleted. Right. So right now, this PC down here is unreachable from this one here. That's not good. We've got to fix that. All right, so what we need to do I want to do this. What I need to do is I need to add one more row, and I need to tell R1, this guy here, that 172.17.3.0 /24. That's this network down here at the very south end. That network is not directly reachable, but we can reach it via 172.17.2.253 and by using our 172.17.2.254 address. And so now, when this guy here sends traffic down to this address, it will still send it here. And there's a quirk here in a second. I'll come back to this. So this guy will send it here. Now, this packet for 172.17.3.19 will match 2 entries: the default and the last one we just added. Because the last one is more specific, R1 will say, that's the route I need to use. I need to send it to 17.2.253. How do I reach that? Oh, I have a route for that. It's direct via this Ethernet interface over here. I can do that. So the packet will now get here, and this router will have a routing entry that tells it to go direct out this Ethernet. Problem solved. So now these 2 PCs can talk to each other. It's a little inefficient, right? Because this PC could as well just send traffic directly to R2. But there's no, well, there are ways to do this, but there's, if the PC just comes up like we've talked about with DHCP and auto configures, there really isn't a good way to give it that additional route. What actually happens is it will send the first packet up there. This router will send it on like we just discussed, but using a protocol we haven't discussed yet, ICMP, it will also alert this PC that, hey, there's actually a more efficient way to get that packet there. Here's a route you should use. And the PC from then on is, if everything works properly, will go directly to R2. If it somehow doesn't pick that up or times that entry out or whatever might happen, some packets might go up here and then come back down this way. But it'll all work. It might not be the most efficient thing in the world until this PC learns they can go directly here. But it will work, right? So that's how we build a routing table. And this is one of those videos that you may want to kind of pause as you go back and rewind and go back and understand each entry we put in and understand how how traffic between any points in this diagram might flow. So I hope, as always, you found this useful, and I will see you in the next video.